Hello class, happy Monday. I'm your new AP Biology teacher, Mrs. Romani. So for this week, we're going to be lecturing on the 5 properties of water. The first one of which is cohesion and adhesion. Cohesion is when H2O or water molecules stick together because of their polarity. So here we have an example of 2 H2O molecules. So here you can see the hydrogen side is very positive while the oxygen side is negative. So therefore, the negative of one attracts the positive of another, and they bond together. This also happens with other molecules besides H2O, which in that case is adhesion.
But Miss Romani, why is this important?
I'm glad that you asked. You see, cohesion and adhesion are used in a process in plants called transpiration, where water molecules, which hold nutrients found in the soil, are pulled up into the plant and all of its leaves by sticking together and sticking to other molecules in the plant.
But Miss Romani, why does this happen? What?
Oh, I'm sorry, Billy. That's the bell. That's all we have time for today. See you guys tomorrow.
Alright, hello class. My name is Miss Crawford. I am substituting for Miss Romani because she took an unexpected week-long vacation. So, today's topic is water's high specific heat. That means that water can gain or lose a lot of heat without changing its temperature. This is because water molecules, when they lose heat, will form a lattice structure to keep the molecules together because they're getting colder. They form this strong hydrogen bond. And the formation of these bonds will make them absorb heat. But this heat is not strong enough to break those bonds. So there's a continuous cycle of losing and gaining heat that will not overall change the amount of heat that it loses or gains very much, meaning the temperature will stay fairly constant. This affects life on Earth by causing it to have a fairly mild climate all throughout the years for every life form so that they can survive in these temperatures. Alright, that looks like the end of the lecture. Are there any questions?
Beep, beep, beep.
Alright, everyone stand in a single file.
Are we gonna die? The fire.
I don't know, I'm just a sub.
Beep,
Don't run.
beep.
Alright, first of all, who did this? Who did this?
It's got water in the humps. Get it? Get
Is
it?
anybody gonna fess up to this? Or am I gonna have to tell Miss Romani when she comes back?
Oh, that's lame.
No one? Okay, moving on. The lecture today is on evaporative cooling. That is when water molecules go from a liquid phase to a gas phase, taking energy and heat with them to cool off its substance of origin. So, when liquid water, has heat added to it, the heat acts as energy that is absorbed by the water molecules, breaking their hydrogen bonds. So when the hydrogen bonds are broken, the water molecules retain this energy and take it away from the substance when they turn into water vapor, which then cools off whatever they came from. Mammals, like humans, use this method to cool down their bodies when they get too hot in the form of sweat. So when the sweat dries off, it will take away their excess body heat. Alright, that would be the end of this topic. Have a nice rest of your Wednesday, everyone.
Oh, dude.
Jeremy. Day 3. It's almost Friday. Alright. Hello, class. Today's topic of conversation is that water is the solvent of life. This is because water has a highly negative region which attracts the positive regions of ionic and polar substances. That causes them to lose their intermolecular forces and dissolve into water. So, water will dissolve most every substance that is polar and ionic, but not nonpolar because those have the same general charge throughout the molecule. This is very important because this uses the nutrients in blood cells to carry them throughout the bodies of animals and humans alike. And that is how that is important. Is that a spitball?
No.
Are you spitting on the board?
No.
What is wrong with this
Oh,
class?
is that the bell? Goodbye.
This is supposed to be AP Bio. I'm done.
Class, I'm back. Because somebody, Jeremy, I'm looking at you, scared away the substitute teacher. So the last property, the final, fifth property of water, is floating ice on liquid water. How this works is ice is 10% less dense than water. It's like that because as water slows down, the molecules begin to form a lattice structure with hydrogen bonds in between them. And because the bonds are at an arm's length, so further away, it makes it less dense than water itself is. The density means that it floats to the top. Now, because ice floats to the top, it means that the entire lake won't freeze over itself, only a top layer. And if only the top is frozen, the organisms that live in the ocean or the sea can continue to live and survive despite the ice and the cold winter weather. Okay, so that concludes our lecture on the 5 properties of water. Now, you will have a timed essay on Monday and a bunch of homework every night, then the AP exam, which most of you will fail. But to make up for that, there's an extra credit project where you can explain the 5 properties of water in a skit or song of your choosing.
No.
Goodbye.